Roller coaster rides have many changes in speed and direction and acceleration. And when a roller coaster changes speed, the rate of change of the speed is the acceleration of the ride, which can be seen here. As you see, this is a typical velocity versus time graph, and as the time is right here and the velocity is increasing, the acceleration has this upward slope as represented by A1. Then when it reaches T sub 1, where it reaches the highest point of its velocity, which would be on a roller coaster, which would be at the very bottom of the hill, the first hill, you can see that the acceleration has that slope of 0. And then right after that, T sub 1, which would be right after the bottom of the first hill, you can see that the acceleration has this downward slope at A sub 3 because of what the derivative is. And then roller coasters also have many common misconceptions about acceleration and velocity. First one would be that changing the height of a roller coaster will significantly increase the speed and acceleration, but changing the height of a roller coaster will actually not do anything to affect the acceleration. The acceleration would be more based on the angle of descent, and the closer the angle of descent would be to 90 degrees, the higher the acceleration would be, and it'd be close to 9.81 meters per second because it would be close to a free fall at that angle. And actually with the velocity, the greater the drop height, the less initial velocity actually influences final velocity, and the speed is not directly proportional to the drop height, but to the square root of the drop height. So in order to double the speed of a roller coaster ride, you need to quadruple the height of it. So increasing the height has actually kind of a minor effect on the speed unless you increase the height dramatically. Also, another one is that acceleration increases on a roller coaster with the weight of a rider, when actually the acceleration of a roller coaster is independent of its mass. So it doesn't matter how heavy the riders are or how heavy the car is, the acceleration is independent of that, and it's based on, like I said previously, the angle of descent and how close it is to 90 degrees.